So Laplace inverse means if we did in the last chapter Laplace transforms, if f of t is the function given, we are finding the Laplace of this f of t, then we have represented in term of a bar of s. We are represented as a bar of s, that is Laplace transform. So now if you find this a bar of s, which is Laplace transform, if you find the inverse of this, we will get it f of t, that we are studying in this chapter, Laplace inverse. So whatever the formula we have learned in the Laplace transforms, that becomes like a reverse way, it becomes a formula of Laplace inverse. Like we know that Laplace of a is a by s. So Laplace inverse of this a by s, now it becomes a. Similarly, Laplace of, we know that e to the power of at is equal to 1 upon s minus a. This one already we have studied in the last module. Laplace of e to the power at is 1 upon s minus a. So if Laplace inverse of 1 by s minus a, if you find it, you can write here just e to the power of 8, just opposite. Similarly, Laplace of sine of hyperbolic functions, directly formula we have remember that a by x square minus a square, right? So Laplace inverse of a upon s square minus a square, we can write it sine of hyperbolic of 8. Similarly, Laplace of cos of hyperbolic of 80 is s upon s square minus a square. Laplace inverse of s upon x square minus a square, we can write it cos hyperbolic of 8. And all the formula is like same only. Sine of 80 we studied that a by s square plus a square. A upon s square plus a square, we can write it sine of 80. Laplace of cos of 80 is equal to s by s square plus a square. The Laplace inverse of s by s square plus a square becomes cos of 80. And last was Laplace of t to the power of n is n factorial divided by s to the power of n plus 1. So here also we can write it here. Laplace inverse of, if given 1 by s to the power of n plus 1, you can bring this n to the power of this n factorial this side. Or if you want, you can write it here also, no problems. That becomes t to the power n by n factorial. So these are the 7 formula which we studied in the Laplace. Same reverse, it becomes a Laplace inverse transform. This is the formula. Now we'll see the questions here. Some basic type of questions if you given, like consider is going to find the Laplace inverse of 1 upon s minus 2 plus 1 by x square plus 4 plus something is given like this here. Like this one is given. So this is Laplace inverse is given, have to find it here. So we can split in the separate forms here. 1 upon x minus 2, individual separate. 1 upon s square plus 4. And this is Laplace inverse of that 2s by s square plus 9. So we know that this is 1 upon s minus a. So 1 upon s minus a, we can write e to the power of 80. So a is here 2. So this one inverse we can write e to the power of 2t. Like this is the formula. 1 by s minus a is e to the power of 8. Similarly here given here 1 upon s square plus 4. There is no formula for the 1 by s square plus 4. If this one formula is there, 1 by s square plus a square. If a is there, then we can write it here. This one inverse is sine of 80, right? So whatever the a is there here, a square, that should be there in the numerator also. So here how much is there? That is 4, which means this is 2 square. So I can write it here like 1 upon x square plus 4. Yeah, s square plus 4, which is given, we can write 2 square. So a is here 2, so numerator also should be there here 2. So just to multiply with 2 and divide with 2, value will not change. So now this formula is a by s square plus a square, we can write it sine of 8. Similarly here also, this 2 is the constant we can take outside, and here this is a square is 3 is there, and this is s by s square plus a square is cos of 3t, we can write. So directly we can write it here s by, this is s square plus 3 square. So e to the power of 2t as it is only. This one half of 2 into s square plus a square means a by s square plus a square, which is sine of 80. This one 2 as it is. This is s by s square plus a square, which is I can write it cos of dt. So this is f of t, and this is the inverse of Laplace. So this type of basic questions if given here, you can solve by this method. One more questions, basic questions I will do it, then I will go to the properties. Laplace inverse of, like, consider given 1 upon 2s plus 4 plus 1 by, yeah, you can write 4 by s square plus 16 plus 1 upon s to the power 3, and so on is given like this. So we can split separate here 1 upon 2s plus 4. Whatever the basic formula you know, based on that one you try it, will get it. Then nothing to remember. If you know the Laplace inverse will be very easy. I split all the terms separate here. So now this one is given 1 upon 2s by 4. There is no any formula which is giving the multiple of s. Multiple of s is nothing is there in this. Or then Laplace, if you know, then you can see here, this is just reverse only. So there is no any terms which is multiple of s. So here is 2 is given, I can take 2 outside here. So if I will take outside here. So I will get it here 1 upon, this one is s, and this becomes 4 by 2, which is 2 more. Right? So what you can write like this also. Laplace inverse of 1 upon 2 I can take outside here, so it becomes s plus 2. This is the Laplace of a by s square plus a square. So directly we can write it here sine of 40. This is 1 upon t to the power n. So we know that Laplace of t to the power n is n factorial by s to the power of n plus 1. So this is given here, n plus 1 is t to the power n by n factorial. So here n plus 1 is, which is given 3. So n plus 1 is 3 means n is equal to 2 actually. So we can write this one here t square by 2 factorial. This one now we can take 1 by 2 outside here, so it becomes 1 upon s plus 2, which is e to the power of minus 80. So e power of minus 2t I can write it, plus this is sine of 40, this is t square, and 2 factorial is 2. This becomes f of t. So in the PDF which is given first questions, Laplace inverse of 5s minus 4 divided by s square plus 4. So here 5s given here, this is 5 here. So you can split this one separate, and this term is separate here. So I can write it here, Laplace inverse of 5s divided by s square plus 4 minus 4 times of Laplace inverse of 4 by s square plus 4. So here 5 is constant here. You can take outside. S by s square plus 4 I can write cos of 2t. So this is 5 into cos of 2t. Minus as it is only, this is here 4 means 2s square. This is 1 by s square plus 2s square. So here we need to do a here. So a is here 2. So this is 2. But the term is here 4. So I can write it like this also. So this 2 will go with the formula only. This 2 will leave as it is only. So 2 into this one formula is a by s square plus a square, which I can write it sine of 2t. This is the f of t. Now we'll see the properties here. First one is shifting properties. Shift property. So like that which we studied in the Laplace, same here you have to understand in the inverse. So first I will write in the Laplace which we studied. That will be more easy, because Laplace we have done so many classes and so many lectures we have done, and we have taught you properly. So that Laplace, if you know inverse, is just you have to think in the reverse way. Okay, so Laplace shifting property, we know that if you know Laplace of f of t is equal to a bar of s, then if given Laplace of e to the power of at f of t, then we can write same a bar of s, just we have to replace s with s minus. This one we did in the Laplace. This is the Laplace transform. Now here, this is the final here. If e to the power a2 into f of t given, so we can write Laplace of like a bar of s and s replaced with s minus a. This one. Now this one if given, Laplace inverse now a bar of s minus a given. So we can write here e to the power at into f of t. This is the Laplace inverse. So just opposite here, if given e to the power at into f of t, we can write a bar of s minus a. Now inverse, if we are finding for a bar of s minus a, we can write e to the power of at times f of t. So we'll see the example here. Consider question is given here. Find the Laplace inverse of 2s upon s square plus 2s plus 2. So we know that there is no any formula like which is giving the factorizations in the denominator, because all in the form of either the factor forms or a square forms here. So we'll try to first this term's denominator is try to convert in the form of factor. So here I can write it this one here, s square plus 2s plus 2. I can write like x square plus 2ab. 2ab means a is s, b what will you substitute it here, so it's become 2s. So only one you have to substitute. So this is a square plus 2ab. b is 1, so b square should be also 1. And we have to bring it 2 here. So we already 1 we got it here. So if I will add it once, so it becomes the same values, this one. This value and this value is the same only. I written in the form of a square plus 2ab plus b square and plus whatever the remaining terms required to make it this terms to be equivalent. So this here to here, this terms I can write it here, s plus 1 whole square, and this one I can write 1. So we got it Laplace inverse of 2s divided by Denominator if you x plus 1 whole square plus 1. If you expand it, you will get the same thing only. So there nothing changes here. Just I written in the form of that factorization forms. So now you can see here, okay, this one is something which is given replacement here. S replaced with s minus 1 they did. So that's why here displacement happen here. So if this is replaced by something, so this also should be replaced by something, because we have done in the Laplace transforms. If you are some formula you getting here s by s square plus a square, and e to the power at for replacing s replaced with s minus a or plus a. So we are replacing in the both numerator and denominator everywhere. So here if replacement happen, so definitely having the replacement also in the denominator, but maybe simplified and given only 2s. So we can write it also in term of, I can write like 2 here s plus, I can write it here, I want to become say s plus 1. So if I will write it here like 2, so 2 I can take common here. So this becomes s by s plus 1 whole square plus 1. So now you can take here 2 common here, right? So 2 if you added here, so we have to subtract it also here 2. Getting? I added 2 and subtracted 2. So value will not change. Any doubt till here? So Laplace inverse of, I can write this terms is separate with this, and again this one with this. So I can write here 2s plus 2 by s plus 1 whole square plus 1, and this one I can write minus Laplace inverse of 2 by s plus 1 whole square plus 1. So I can write Laplace inverse of this one 2, if you take the common, I will write s plus 1 by s plus 1 whole square plus 1 minus, here a is 1 here, this is 1 square only, so there is 2 is constant actually. So Laplace inverse of 1 upon s plus 1 whole square plus 1. So we can write it here, Laplace inverse of, this one is actually s by s square plus a square, where s replaced with s minus 1, right? So there is given formula for the s. This is actually is what, like s by s square plus a square, which is 1, and they replace here s replaced with s minus 1 means plus 1. So definitely this one is the form of, where a is what, minus 1 here and s minus 1. So you should write e to the power at into f of. If you have not understand, means you have problem with the Laplace transform. You have to go through my all the videos from the Laplace transform, then it will be understand more easy, because I am teaching the same method which I have done in the Laplace transform. I am not using any of the properties in the different way, just whatever I taught in the Laplace, that way only I am teaching, just inverse way. So here s by s square plus a square means this is cos, s by s square plus a square is cos of 8, a is here 1, and s replaced with s minus a given, that's why it becomes plus. So it becomes here e to the power of minus t into cos of minus 2, this one as it is only, this is 1 by s square plus a square means sine of at, a is here 1, sine of t, and s replaced with s minus 1 given here means a is minus 1 here, so I can write e to the power of minus t sine of t. So the final answer we can write f of t is equal to e to the power minus t common here, that is cos of t minus 2 sine of. And similarly in another question is given here, Laplace inverse of 2s plus 3 by s square plus 2s plus 2. Same question, but here given 2s plus 3. So we'll see how to do it. Here factorization, same thing we can write here, Laplace inverse of 2s plus 3 divided by s plus 1 whole square and plus 1 square, which it did in the last question also same. Now here already 3 is given, so you have to not add and subtract anything. Here I can write it Laplace inverse of 2s plus, I can write 2 plus 1, because this 2 I can take common, so it will be replacement with s plus 1. So Laplace inverse of, I can write here 2 common here, so it becomes s plus 1 divided by s plus 1 whole square plus 1 square separate, and this one 1 upon s plus 1 whole square plus 1 square is it separate. So here if you see, this is 2 as it is only constant, s by s square plus a square, I can write it here cos of at, and that a is replaced with s minus minus 1, so you can write e to the power minus t and cos of t, and here this one is a plus is given here and s replaced with s minus 1, so plus I can write e power of minus t sine of t. Getting? So final answer f of t you can write like this. So just we have to find the denominator in the factor and have to convert in the Laplace transform the way you can convert easily, and then you have to think about the formulas, which is 7 formula is there, you solve it. Now second property is